Dear student, welcome to my channel. This is the 28th video on C programming, and in this video I am going to continue with the array exercises. Now in this video I am going to take 31 to 35 exercises, and in the next video the next program. Now we will see the first program. Write a C program to find the frequency of each digit in a given array. So for example, how we require to write down this program. For example, we will accept the array size. After that we will enter the array elements which is of digit, that is one digit between 0 to 9, and after that we will display that elements, and after that it will display, for example, 1 is repeated for 2 times, 3 is repeated for 1 time, and 2 is repeated for 3 times. So in this way we require to show the output. So to do the programming, what we require to do, we are accepting the array size, after that accepting the array elements, and after that we are printing the array elements. So this is the program up to this. So in my previous video I have already explained such type of program. Now we will see. So for this program I am using one variable, that is array variable frequency d of 10. Now d of 10 can store the 10 elements from 0 to 9. Initially I am using this as a counter. So initially, before starting the program, I am storing 0 to all the location. So this frequency d contains the array which has 10 location, and all 10 locations are filled with the 0. So first location will point out 0, second will 1, third will 2, 3, 4, 5, 6. So after that what we require to do, we require to use the nested loop. Now for I equal to 0, I is less than n, I plus plus, we will take the array first element. So first element is 1. So we will check that if this element is equal to j, that is j is going from 0 to 10, that is 0 to 9, that is nothing but this frequency. And if this element is what, array of I, if array of I match with the j, then we are incrementing the counter. For example, see, this element is 5, then what will happen, when j becomes 5, then array of I equal to 5, then at that time we are incrementing the frequency of at which location, 5th location. So in this way we are doing the program. So this is only the logic, and this is a smarter way to, for each array entry we are checking the 10 digits, whatever match we are incrementing that frequency by 1, and this is nothing but the end of the for loop, that is nested for loop. After that we have to print. So I am printing only when the frequency is greater than 0. So therefore for I equal to 0, I is less than 10, I plus plus, if frequency of I is greater than 0, then it will print percentage d, element present for percentage d times. So percentage is d is nothing but I, and frequency of di is nothing but that count. So in this way you require to use the nested loop concept. Now we'll see the next program. Write a program to search for a given element in an array using the linear search technique and display its position if found. That is nothing but the linear search program. So for example, here the locations when 0 to 4, they are actually 1 to 5, and we are storing the elements. So we want to search the element 40. So what we will do, we will check with the 10, 20, 30. If it is match, we will break, and we will set particular flag condition, and after the loop we will print. If this particular flag is set, the element is found, otherwise element is not found. For example, see, we are accepting the array size, accepting the array elements, displaying the array elements. After that, which element we search, if that element is present, it will print element is present or element found. Now this is the program. See, enter the size, enter the array elements, and enter the element we search. So when you are doing the programming, at that time don't write down the entire program. First you write down this particular portion and check whether it is working or not. When it is working, then it is very easy to debug the program, even if error is in the next part. Now initially what we are doing, we are going from, for I equal to 0, I is less than n, I plus plus, and I am making flag equal to 0. When that array element match with the our element to be search, at that time what we are doing, flag equal to 1. So flag is 0 by default, but when that element match with the array elements, the flag becomes 1, and we are breaking the loop. Break is always from the loop. So there is only one loop, that is this for loop. So we will come out of the for loop. In for after coming out of the for loop, if flag is 0, it will print element is not present, otherwise it is print element is present. So in this way we can do the linear search. Now we can see the next program of binary search. It is a very easy program. Only you require to understand the logic, and the main important is that how to or how much time we have to iterate the loop. So I will take first example of binary search, and then I will explain the code. Write a C program to search for a given element in a sorted array, because for binary search we require that array to be in sorted order. Using the binary search technique and display its position if found. Now we require to follow the binary search, but binary search is more efficient than linear search, because in binary search the efficiency is in the logarithmic, or complexity is in the logarithmic factor. Now see, for example, here we have accepted the 7 elements, so array's locations are from 0 to 6. Now I have stored all the elements 5, 10, 15, 20, 25, 30, 35. So array should be in sorted order. Then we require to search the element. Now what we will do, initially we keep low equal to 0 and high is equal to whatever that n minus 1. Now elements are 7, so they are going from the span the location 0 to 6. So low is 0, high is equal to 6. We will calculate the mid. Mid is nothing but 0 plus 6, that is average. 0 plus 6 by 2, which is equal to 3. Now we will point out, see, these 3 pointers are there. One will point out at the low, which is equal to 0. One will point out at the high, which is 6 location, that is 35 element, and after that mid is there, and that value is 20. Now what we have to search, we have to search 30. Now obviously 30 is present in this side or this side. So when 30 is present on this side, what we require to do, we don't require to change the high, only we require to shift low to this location, because this is already we are going to check whether it is match or not match. So that's why we are searching, so we are shifting this. Now see, initially if n elements are there, in the next iteration if element is not found, the our array will, or search area will be reduced by half, that is n by 2, because in the next iteration we are not taking the half of the elements. So that's why it is very efficient. Now see, 5, 20, 35. Now what we want to search the element is to be 30, so it is present this. So what we require to do, we are shifting our low. See, what is the formula? When the element is present is on the right hand side, what is the formula? We are changing the low, which is equal to mid plus 1. Then low is equal to 4. Low becomes 4. Initially it is 0. Then high is 6, because we are not going to change high. Then mid becomes a 5 element. So 5 element is 30. Next, in iteration we want to search which elements? 30. 30 match with the 30, and the program ends. Now here program ends, that is means what? We require to do the break also. Now see, low equal to 0, high equal to n minus 1. When we are going to program, unless and until low is less than or equal to high, because low at the 0th location and high at the highest location. So while low is less than or equal to high, we are continuing the program. What is our first step? We calculate mid. What is mid? Low plus high by 2, that is nothing but average. If array of mid location, if match with our element, means that element is found, then at that time what we are doing, flag equal to 1 and break. Now for this if, two statements are there, that's why I have written open and closing parenthesis. Now if not match, what is the next condition? If array of mid is less than x. Now here what we require to think, here our element what is to be check is greater, so most probably it will be present on the right hand side. So what we are changing, we are changing only low equal to mid plus 1. Else what will the condition, that whatever the we want to search the elements, that is present on the left hand side. So what we are doing, we are checking that this high is equal to mid minus 1. So only we require to change high is equal to mid minus 1. So only this much logic is required for this program. Now we will see the next condition. For example, we want to search the elements 5. So initially our low is 0, high is at 6 location, and our mid calculation is 3, and which is 20. So now we will check 35 element, we compare with the 20, whether it is greater or less. If it is greater, we will shift here, but it is less. So what we require to do, we are not changing the low, but we are now changing the high, and which is equal to mid minus 1. Now see, low equal to high is equal to mid minus 1, which is equal to 2. Low remains same, and again we are calculating the mid. Now mid is this. Now again we check 5 with this. Now here again not match, and it is present on the left hand side. Again we are checking this mid to the low mid minus 1. So they are pointing to the same location now, and next time match will happens. So in this way we can perform the binary search but for that two conditions are there, that elements is to be should be in sorted order. Element is to be only one condition, element is to be in sorted order. And see, this is only the condition while low is less than or equal to high. Calculate the mid, check with the middle elements, if match then break, otherwise shift the pointer. Either if the element is greater, shift low value, and if the element is smaller, shift the high value. So in this way we can write down the program. See size, array elements, enter the element to be search, and this is the loop. And in any case, if our flag becomes 1, it indicates that element is found. So element found at %d position we can write down, that is nothing but actually mid location, otherwise element not found. Now this program is required to understand, that is the important logic, that is a program to insert the element at a particular location into the array. Now what are the valid location? We can insert the element at 1, 2, 3, 4, 5 and 6 location. Now when we insert the element, what we are doing, we are shifting to the right hand side, and our array size increases by 1. Now see, 10, 20, 30, 40, 50, these are our array elements, and all next locations are always garbage location. Now what is the position 3? So we want to insert the new element at the third position. So 10, 20 will remain as it is. Now what we require to do, we can't shift 30 to 40, then it will overwrite 40. Here 30, here 30. So what we are doing, we are going at the last. Now this is the 50. So we are shifting to the next location. Now next location and this location contains the 50. After that what we are doing, this 40 is transferred to here. Now here 40, here 40. After that we are transferring 30. So 30 and 30. Now here we stop the loop, that is shifting of the elements, and we will insert the element 25 at this location. So in this way what we require to do, we require to do the shifting of the elements to the right hand side. See, whatever I have explained, initially this location contains the garbage value, so we are moving this 50 to here, so both location contains 50. After that we are shifting 40, then we are shifting 30, and after that we are placing this 25 elements here. Now here what is the change, that is our n get increases, that is n becomes n plus 1. Now see, we require to first understand the logic. The remaining program is very easy. Now for example, n equal to 5, position equal to 3, the element to be inserted is 25, and as our n changes, so we are storing the temp n into the temp variable. Now only what we require to do, a of n is equal to a of n minus 1. Now see, here what we have shifted, this element we have shifted here also. So that is what a of n is equal to a of n is equal to a of n minus 1. So n minus 1, because array elements are stored from 0th location, so n is 5, so 5 minus 1 4. So a of 0, that is a of 4, 0 1 2 3 4, a of 0 is shifted to a of n. That's why a of n minus 1 element is shifted to a of n, and then that's why we have shifted a of a4 element to the a5. Now we decrement the n, that's why we are storing the value of n into the temporary variable. Then we will shift a3 to a4. Now see, the shifting takes place at the right hand side. a4 is copied to a5, then a3 copied to the a4, then a2 copied to the a3, and now here we require to stop at a particular point. So when we are stopping this procedure, so we are doing this procedure while n is less than or equal to position. When n becomes small, we will stop here, and at that location we will shift, or we will put the element at that particular location. So after the loop, what we are doing, a of n equal to x, so n becomes 2, that's why we will coming out of the loop, because position is 3. So n decrements, it will start with the 5 then decrement. So when n becomes 2, we will come out of the loop, and at that location we insert the element, that is a of 2 equal to 25. And after that, when we are printing the array, we require to print with one more extra element, because we do the shifting operation. So what we are doing, we are printing and we set to the temp plus 1. So this is only the logic. So what we require to do, we require to just shifting, that is we are moving a of n to a of n minus 1 to a of n decrements. Do this operation unless n is greater than or equal to position. Now to understand this, how to remember that this should be n is greater than or equal to position, for that you require to do some paperwork, and on that paperwork you will come to know that where to stop the loop. Otherwise it is very difficult to remember each and every program, but once you do the practice it is very easy program. Now see, I have shown same. See, a of n is equal to a of n minus 1. So a of n is 5. 5 means 4. A of 4 is shifted to a of 5. A of 4 is shifted to a of 5. So in this diagram also I have shown the operation. Now the writing of the program is very easy. Size accept, then accepting the array element, enter the position, what is the position, and at that position what to insert. As in our program, as n is changing, so we are storing the n into the temp variable. Then we want to print the array element, so I am printing that with the temp plus 1 because I am showing that garbage value, that's why I am using temp plus 1. So this is the important loop. While n is greater than or equal to position, array of n is equal to array of n minus 1. Then here I am printing, this is not required compulsory, but here I am printing that in every loop how that changes is happening. So this is compulsory, this is not compulsory, this is optional portion, but if you want to check whether your logic is working or not, you can put intermediate statement like this, and once the program is ready or correct, you can remove the statements or make them comment, and after that n minus minus. Then when you come out of the loop, then at that time n becomes 2, and at that location you require to insert the element. So array of n is equal to x. Now n decreases, so that's why n is equal to 10 plus 1, and here we are printing the array elements. Now when we do the insert, we are moving right hand side. When we are deleting, we are moving this side, that is nothing but the left side. And after that array size is decreases by 1, that's we require to change. And while insertion, we are changing the n value compulsory, and here when we are using the delete, we are changing the position variable, that's why, but n does not change, so there is no need to store in a temporary variable. Now see this program, a program to delete an element at a particular location in an array. Now see, these are the 5 elements are there stored in an array. So valid locations are, actually in array they are stored from 0 to 4, but what is the valid location from human point of view? 1 2 3 4 5, and for we have stored this value. Now we want to remove the element from the 30. So what we are doing, we are moving this 40 element first here, then we are moving 50 element to this here, and after that we are decrement the size of the array. So this is nothing but the procedure. See, we are moving this 40 element to here, so this 40 and this is also 40. After that we are moving this 50, so this 50 and this 50, and after that what we are doing, we are cut this size. This is only the logic. So what is the procedure? A of position minus 1 is equal to a of position. Now see, position is third, so what we have to do, see, this is the third position, so we can see from the array location. So what we are doing, we are deleting this element, so 40 we require to shift here. So what is the procedure? A of position minus 1 is equal to a of position. A of position is 3, which is nothing but the 40 element, which should be shifted on the less than sign, so pos minus 1, position minus 1, and after that we will increment the position, and we will stop this process while position is less than n. So as I already told, when greater than sign is there, we use decrement, and when less than sign is there, we use increment. So here we are incrementing the continuously position, and for this, whether it should be position less than n, position less than or equal to n, we require to do some work, and after that we can, that is paperwork, or after that it can easily understand that the loop should be executed for position less than n. After that we are decrementing the size of the array. Now see, the program is very easy. Now see, we are storing the array elements, and after deletion we are decreasing the size of the array. Accept the array elements, position, then array elements are there. Array of position minus 1 is equal to array of position. This is compulsory option, this is only just I have printed intermediately. Then we are incrementing the position plus plus, so this will just shift on the left hand side. When we come out of the loop, we will do n minus minus, and we will print the array elements. So this is all about the program of linear search, binary search, insertion and deletion, and in the next video I will continue with the next exercises on one dimensional array. Thank you.